Welcome to eCruz Learning, where it's just that easy with your favorite host, Master Cruz. And today we're going to talk about graphing linear inequalities. So here we go. We have, first of all, linear inequalities, and inequalities are less than or equal to. That is this symbol because it almost looks like an L. I hope you can see that. And then you have this symbol, which does not look like an L. So it's the greater than or equal to symbol. And every time that we have the less than or greater than or equal to, we're going to use a solid line to graph, just like we've done in the past linear functions. When you just have less than, but there's no line at the bottom, you just have greater than, but there's no line at the bottom. When you graph them, this is going to translate into a dashed line. So basically what this means is that if you have the line at the bottom, the lines fill in the gaps, making a solid line. All right. So this solid line means that all my points, all my answers are included. Not line, not equal to means just dashed. And the points that are along this boundary line are not included. So let's talk about the X and the Y coordinate plane. This is the coordinate plane with the X axis and the number line on the y-axis, and then you can plot points like point A, point B, and point C. So these are points, and then graphing inequalities, what it makes it different is the following. You have a boundary line, and this boundary line divides the entire graph into two half planes. One half plane I have shaded, and the other half plane is not shaded. Okay, so the shaded region actually contains the solutions to my inequality. So if I give you this graph and I ask you, hey, are these point solutions to this inequality? What can we say? Well, first let's look at point A. Point A is 0, 0. Is 0, 0 in the shaded region? That's a question you gotta ask. And the answer is no. Therefore, this point is not a solution. So I'm going to write down, no, this is not a solution. How about point B? Well, point B is in the shaded region. So point B is a solution. So I'm going to put yes. Point B is a solution to this inequality. How about 0, -2? Well, it turns out that C, 0, -2, is actually on the boundary line. So the question is it a solution, yes or no? What do you think? Well, here's the deal. It depends on the boundary line. If the boundary line says less than or greater than, it's going to be a dashed line. Now remember, if it's dashed, it does not include the points. So for this specific graph, this point is not a solution. However, if this boundary line was a solid line, like the one above, the solid line, okay, if that was a solid line, then this point will be a solution because it equals to all the points on the boundary line. So that will make a little bit more sense when you're practicing. But remember, if it's dashed, it does not include it because it's not equal to. Equal to is a solid line and it is included. So let's graph these. Example 1. How can we graph these in slope-intercept form? Well, here are the steps to graph an inequality. If I give you a linear inequality, example 1, it says y is greater than 2x minus 3. The first thing that you could hopefully see is that this is in slope-intercept form. So you can automatically see the slope, which we denote with the letter m, and we can see the y-intercept, which is the b variable, because this is y, right? This comes straight from y equals mx plus b. So that's where that is coming from. That means that the 2 is the slope and the b is the y-intercept. So here we go. The way that we plot this, and we get, this is just like graphing linear equations. This is why it's so important that you know how to graph linear equations first, is that you got to plot the y-intercept. Well, the y-intercept is the number by itself. It's the number by itself, the one without the x. So it's b. So this is -3. What is the slope? Well, the slope is 2. We talked about it. But we don't just want 2, because when we're graphing, slope is rise over run. It's rise over run. So therefore, you need 2 numbers. So you have to take the slope and write it over 1. You have to take the slope and write it over 1. So here we go. Let's plot it. If you plot the y-intercept is -3. So I'm going to go to my graph. My graph is not perfectly labeled. I'm just going to go here at -3, and I'm going to plot a point. That is step 1. Okay. And then step 2, it says from the y-intercept, count rise over run, which means because this is positive, I'm going to count 2 up. So from here, starting from the -3 that I just plot, I'm going to count 2 up, which means I'm going to end up at -1. Hopefully that makes sense because I'm going 2 up, and then 1 to the right. So I'm going to be here a +1. And there is another point right here when x is 1 and y is -1. Now, usually here, you would just connect the dots. But now you have to be careful. You have to check if this is going to be a solid line or a dashed line. So you have to check if solid or dashed. Well, because this does not say equal to, right? If it had the line at the bottom, it will be equal to, but it doesn't. This is going to be a dashed line. So I'm going to come here and I'm going to draw a dashed line. So here we go. Dashed line, dashed line, dashed line. Okay. And the last part is, where do I shade? Do I shade above or do I shade below? Well, I need to shade the region with the solution. So there's 2 ways of knowing which side you're going to shade, right? The first way of knowing this is by looking at this sign. You have to look at the inequality sign, which is right here, and notice this is a greater than sign. So the first way to check this, which side to graph, is that you have to go to the side that it's greater. So I'm going to check my y-intercept, which was the first point that I plot right here, the y-intercept, and it is a -3. And I'm asking you, where are the numbers that are bigger than -3? Now you have to stay on the y-axis. You cannot move left or right. You have to stay on the y-axis. So do I have to move up the y-axis to get to the numbers that are greater than -3? Or do I need to go below the y-axis? Well, I need to move above the y-axis to get numbers that are greater, which means I'm going to go along this line that I graph, and I'm going to shade this region above. And every single point that it's above that line, okay, every single point that it's on this side of the graph is a solution. So that's one way of knowing that this is the solution, by looking at the inequality sign. What is the other way of knowing? Well, I wrote it here for you. You could check if 0, 0 is a solution. You can always do this. How can you check if 0, 0 is a solution? Well, what you do is very simple. A lot of students prefer this way. So you just write 0, 0, and then you go to your actual problem, the original problem, y is greater than 2x minus 3. So I rewrote it here, y is greater than 2x minus 3. And instead of y, I'm going to replace y with 0. And instead of x, I'm going to replace x with 0. And then I'm going to simplify. I just write greater than, or 2 times 0 is 0. So anything times 0 really cancels. It's gone. So just bring the -3 down. And you have a question to answer. Is 0 greater than -3? Is that a true statement? Well, any positive number or 0, it's greater than -3. So the answer is yes. This is true. This is a true statement. Therefore, the side that has the point 0, 0 is the side you're going to shade. Okay, so 0, 0 is right here at the origin. That's why it's one of the easiest points to choose. And you can always choose that one. And if it gives you a true statement, you're going to shade the region that contains that point. The only time that you cannot use that point is if the actual graph goes through 0, 0. And then you could choose any other point, whatever point you like to use, all right? So what happens if you get -3 is greater than -3? Is this a true statement? I want to know, is -3 greater than -3? Well, the truth is that this is not true. This is false. So -3 equals -3, but -3 is not greater than -3. If I were to change that problem and say that -3 is greater than or equal to -3, then the answer will be yes, because it says equal to right here. That line on the bottom means equal to. So if it has it, yes, but if it doesn't, then no, because -3 does not equal -3. All right, Let's graph something in standard form. So what happens in example 2 if I ask you to graph this? Well, there's two different methods that you could graph negative 3x plus 6y is less than or equal to 18. The first method is just write it in y equals mx plus b, find the slope, find the y-intercept, and do exactly what we did on the top problem. Most students like this way, so I'm going to do this way first. Okay, make sure you write both methods. Here's method number 1. I'm going to take negative 3x, check out both methods so that it makes sense to you. And I'm going to move the x from one side of the equal sign to the other. And I can always do that as long as I do one thing, and that thing is change the sign. So it's negative 3x. Now it's going to turn into a positive 3x. I'm going to bring down the 6y because I'm not going to do anything with it. And I'm going to bring down the 18. I'm not moving it from one side of the equal sign to the other. So it's going to stay exactly the same. It's going to stay exactly the same. All right, perfect. Now, this almost looks like y equals mx plus b, except I'm going to have to divide every single term by 6 so I can get my y by itself. So when I do this, then y is by itself. And this is going to say that y is less than or equal to, and notice that I'm keeping the symbols always aligned, okay? I just treat that like an equal sign. It's just an inequality, less than or equal to. And I can simplify here. It looks like I can simplify divided by 3 top and bottom, right? So 3 divided by 3 is 1. And 6 divided by 3 is 2. So this 1/2 x. This is going to be plus. And then 18 divided by 6 is 3. So with this equation right here, I can clearly see my y-intercept, which is the first step that I will use to plot. So I'm going to plot the y-intercept. And the y-intercept is 3. So then I'm going to go to my graph, and I'm going to plot 3, positive 3 over here in my y-intercept. And then I have a slope, and the slope is 1/2. And remember that when I'm graphing, slope is rise over run. So if the slope was negative, I'm going to move down. If the slope is positive, I'm going to move up. But I always move to the right. I always move to the right. So I have a point at positive 3, and starting from that point, I'm going to start counting my slope. So this says go up 1. So this is going to go up 1. And if I go up 1, I can move up to 4. And then I'm going to have to run 2. So I'm going to run 2 to the right, and I'm going to run to 2 on the x-axis. So I have another point right here. Okay, now remember, this is an inequality. So I need to choose, is it dashed? Or is it solid, right? Solid or dashed. You always have to do these 4 steps. Well, when you look at the actual problem, it says equal to, right? This says equal to. Actually, let me look at the one that I'm looking at right here, which is this one that says equal to. So because it says equal to, this is a solid line. So this is a regular line like we do most of the time. It's just a regular line. But then we need to shade a region. Are we going to shade above, or are we going to shade below? There's 2 different ways of knowing, right? So the 4th step is shading. Okay. How do we know which side to shade? Well, I'm going to look at the inequality sign. And the inequality sign says y is less than or equal to. So y has to be less than. So when I go to the y-intercept, which is at 3, this is the first point that I plot on the y-intercept, where are the numbers that are less than 3? Where do I have to move on the y-axis to get to the numbers that are less than 3? Well, I need to move straight down, right? I need to move straight down, or I move straight up, one of those two. So I'm going to move straight down. If I'm going to move straight down, that means that this is the side that I'm going to shade, and I'm going to shade the entire side below that line, okay? The entire side below that line, everything. Remember, it's either you shade above or you shade below. I'm going to shade below. So that's it. That's how you shade it. If you're not sure, remember, you can always use the point 0, 0 for x and y. And then you take the original equation, which is all the way up here. And instead of x, you write a 0. And that's what we did here. Instead of y next to the 6, you write a 0. So you substitute. And then you simplify. Negative 3 times 0 is 0. 6 times 0 is 0. So 0 plus 0 is 0. And then the 18 stays alone. And then you ask yourself, is this a true statement? Is 0 less than or equal to 18? Remember that someone said that this is like an alligator and it eats the bigger number, or like Pac-Man, right? And it eats the bigger number. So this is true. 18 is greater than 0. 0 is less than 18. So this point 0, 0 has to be in the solution area. And it actually is, because 0, 0 is the origin, and it is in the solution region. That is perfect. There's another way that you could solve this. And if you prefer this, you can always use it. And it's usually the way I do it. Instead of solving it to y equals mx plus b, which is method 1, we could use method 2. And I'm going to write down method 2 right here. Now, learn how to do method 2, because a lot of students find it easy, and then you choose which one is the best method for you. If I have the original problem, I can completely ignore the y for a second, because I can make y equals 0. I can completely ignore this and just write this and this part. So that's what I did here. Negative 3x is less than 18. And I just have to do one step, is divide both sides by negative 3. That will give me the x-intercept. That says that x has to be greater than or equal to negative 6. That will be the x-intercept, which means when I look at my graph, I'm going to have a point right here at negative 6. Okay, if I repeat the same process with the y, so this time I'm going to completely ignore the x term, because I'm going to let x equal 0, so I could find the y-intercept, because of the intercept, the other variable is always 0. Then what do I have left? I have 6y is less than or equal to 18. So 6y is less than or equal to 18. How do I solve for y? Just divide by 6 on both sides. So y is less than or equal to 3, which means that the y-intercept is 3. But we knew that. We found that. There's the point. And then I'll connect these 2 points. You still get the same line. The cool thing is that you could do this from here, right? You don't have to write this if you don't want to. If you want to find the x-intercept, just take this number 18 and you divide it by the coefficient of negative 3, and that gives you negative 6 automatically. And so that's negative 6. If I want to find the y value, the y-intercept, I ignore the x, and I just take the 6, this 6 right here, and I divide 18 by 6, and that gives me the 3, which is the y-intercept. So it's actually pretty cool if you understand it. If this method is not for you, it's too complicated, method 1 will always work. All right. The last exercise is one of the easiest ones, I think, but it's important that you know them, because this does not look like y equals mx plus b, but it's not that bad. All you have to do is, if you see y is greater than or equal to negative 5, you just find negative 5 on the y-axis, because this problem is about y. So you're going to go to negative 5, and negative 5, I'm going to say that it's somewhere all the way down here. Okay, I'm going to say that negative 5 is all the way down there. And then is this going to be a solid line or a dashed line? When it looks like it's going to be a solid line, because it has the equal to at the bottom. So all I have to do, this line right here is called a tick mark. That tick mark is used to mark negative 5 on the y-axis. So what I'm going to do is extend this mark, which is called the tick mark. So all I have to do is extend it, right? Make it longer and make it longer. So this is going to go to the right and to the left. And then that's it. That is the graph of y equals negative 5. But this is not y equals, this is y is greater than or equal to negative 5. So where are the numbers that are greater than negative 5? Are they on the y-axis above 5, negative 5, or below negative 5? Well, if I want the numbers that are greater, I better go above, right? Wrong pen. There you go. I want to use the highlighter. So all these points that are above, right? All these points that are above, those are the points. Oops, not that one at the end. Oh no, everything. This is so sad. So all these points, I hope that you get the idea, are solutions, including the points on the line, because this is a solid line. How about if I give you x is less than negative 8? Well, this problem is not about y. This problem is about x. So now we're going to go to the x-intercept, and we're going to find negative 8. So I'm just going to say that negative 8, it's over here. Okay. You don't have to draw a bunch of tick marks. You just mark whatever numbers they give you. And then this one is not less than. This is, sorry, it's not equal to, is just less than. So this is going to be a dashed line at negative 8. So I'm going to go to the tick mark again, which is the mark that we use to mark the number, and I'm going to create dashed lines. Okay, so I'm going to go ahead and do this because these are just less than. There's no equal to. Now, where are the numbers on the x-axis, because this problem is all about x, that are less than -8? Are they to the left on the number line of -8, or are they to the right of -8? What if they're less than? They have to be to the left. So I only care about the numbers that are on this side of the graph. This side of the graph, all these points are solutions, meaning that if I plug in any of these points into this inequality, it will give me a true statement. So that's all for today. This is your boy, Master Cruz, with eCruz Learning, where it's just that easy.